There are many types of diodes available in the market which look identical but differ in their performance parameters. So how do we select the best type of diode suitable for use? We select them according to their specifications like DC resistance, AC resistance, diffusion capacitance, and transition capacitance, etc. Let's see what these parameters are. When the diode is operated in the DC voltage, the resistance of the diode is called as DC or static resistance. From the characteristics of the diode, this resistance is calculated by the ratio of V upon I. As DC source remains constant, we can compute V upon I ratio throughout the characteristics graph. During forward bias, current through the diode increases with the applied voltage. Hence, as the diode starts conducting, its resistance value goes down. Thus, during forward bias, the diode has minimum resistance. On the other hand, this resistance takes a very high value of mega ohms during reverse bias. DC or static resistance plays a vital role in the analysis of clipping circuits or rectifier circuits. When we operate the diode on the AC signal, its resistance does not remain same as that of DC or static resistance. This is because AC signals continuously change in a sinusoidal manner along the axis, taking alternate positive and negative values. Thus, this resistance becomes dynamic in nature. This dynamic resistance is calculated as dV upon dI. This dynamic resistance comes in picture as an important parameter when we deal with the analysis of circuits that work on AC signals. During forward and reverse bias, the diode exhibits two types of capacitances: diffusion capacitance and transition capacitance. During forward bias, free electrons from N side cross over to P side, resulting in change in charge. This motion of electrons depends upon applied voltage. Therefore, diffusion capacitance is defined as the change in charge due to change in voltage during forward bias operation of the diode. CD equals dQ upon dV. During reverse bias, we get change in a charge as majority charge carriers move away from the junction, leading to the capacitance called as transition capacitance, defined as change in charge due to change in voltage. CT equals dQ upon dV.